Hi everyone, myself Vasant Reddy. In this video, I am going to give a slide presentation on support vector machines in machine learning. Let's know what are the topics covered in this presentation. Introduction to SVM, how does it work, SVM parameters, advantages and disadvantages of SVM, applications of SVM, variants of SVM, and finally the conclusion. Let's know the introduction to SVM. SVM it is a powerful machine learning algorithm used for both classification and regression tasks. It is mostly used in classification problems such as text classifications, image classification, and bioinformatics. In the SVM algorithm, we plot each data item as a point in n-dimensional space where n is the number of features you have, with the value of each feature being the value of a particular coordinate. Then we perform classification by finding the optimal hyperplane that differentiates the two classes very well. Let's know how does the SVM work. SVM is a binary classifier that separates data into two classes by finding a hyperplane. Here A, B, C are the three hyperplanes and that maximizes the margin between the two classes. The margin is the distance between the hyperplane and the closest data point for each class. SVM can also handle linear separable data by transforming the data into a higher dimensional space. Identify the right hyperplane. Scenario 1. There are three hyperplanes A, B, and C. Here we have three hyperplanes A, B, and C. Now identify the right hyperplane to classify stars and circles. Select the hyperplane which separates two classes better. In this scenario, hyperplane B has excellently performed this job. From this diagram, we should select a hyperplane which separates the stars and circles correctly. So, taking hyperplane A, it won't separate equally, and C won't separate equally. So, hyperplane B, B is hyperplane which separates stars and circles correctly. How does it work? Identify the right hyperplane. Scenario 2. Here we have three hyperplanes A, B, and C. And all segregate the classes well. Now, how can we identify the right hyperplane? Here, all the three hyperplanes A, B, and C are equally dividing the stars and the circles. But we should choose a single hyperplane so that we are maximizing the distances between the nearest data point. And the hyperplane will help us to decide the right hyperplane. This distance is called as a margin. Now from the three hyperplanes, C is the hyperplane in which when the stars are a distance between maximum and even the dots circles are far away from the hyperplane. Here you can see that the margin for hyperplane C is high as compared to both A and B. Hence we name the right hyperplane as C. Another lighting reason for selecting the hyperplane with a high margin is robustness. If you select a hyperplane having a low margin, then there is a high chance of misclassification. How does it work? In the scenario below, we can't have a linear hyperplane between the two classes. So how does SVM classify these two classes? Till now, we have only looked at the linear hyperplane. SVM can solve this problem easily. It solves this problem by introducing additional features. Here, we will add a new feature. It's a formula where z equals to x square plus y square. Now let's plot the data points on axis x and z. All values of z would always be positive because z is the squared sum of both x and y. Here z equals to x square plus y square, so it is always positive. In the original plot, red circles appear close to the origin of the x and y axis, leading to a lower value of z. The star is relatively away from the original results due to the higher value of z. SVM parameters. C is a regularization parameter that controls the trade-off between maximizing the margin and minimizing the classification error. Gamma. Gamma is a particular parameter that controls the shape of the decision boundary. High gamma values lead to more complex decision boundaries. Kernel function is a function that transforms the input data into a higher dimension space. Common kernel functions include linear polymorphism and radial basis function. Let's know some of the advantages and disadvantages of SVM. SVM can handle high-dimensional data and large datasets efficiently. And SVM is robust to overfitting due to its ability to control the complexity of the decision boundary. SVM can handle non-linearly separable data by using kernel methods. Now, going on to the disadvantages. SVM is sensitive to the choice of kernel function and its parameters. SVM can be computationally expensive for large datasets and complex kernel functions. And SVM does not provide probabilistic outputs, which may be necessary for certain applications. Now let's know some of the applications of SVM. Image classification. SVM has been used to classify images based on their content, such as detecting objects in images. Okay. Text classification. SVM can be used to classify text documents into different categories such as spam filtering or sentiment analysis. Bioinformatics. SVM has been used to classify genes based on their expression patterns or to be predict protein interactions. Variants in SVM. One class SVM support vector recognition and multi-class SVM. So one class SVM used for anomaly detection by finding a hyperplane that encloses a single class of data points. Next one is SVR, used for regression task by finding a hyperplane that minimizes the distance between the predicted value and the actual value. The last one is the multi-class SVM, used for multi-class classification by constructing multiple hyperplanes to separate the different classes. And coming to the conclusion, SVM is a powerful machine learning algorithm that can handle high-dimensional data and large datasets efficiently. SVM can handle non-linearly separable data by using kernel functions. And SVM has a variety of applications in fields such as image classification, text classification, and bioinformatics. Thanks for watching.